Okay, so like I mentioned in class, the notes for 1.3 are lengthy, and it's just because it's an attempt to show you each type of problem that you might encounter when you go through the homework for this section. But again, a lot of these are pretty straightforward in terms of you just read it carefully, you're just doing a basic comparison, or you're doing a trial and error. So again, for these that I've not worked through, and we'll try to kind of give you some hints, and then I want you to try them, and then go back and check your work on it when I post the completed notes tomorrow. All right, so the first one here, again, I just kind of gave you some hints. This is going to be a trial and error. You're looking at how many boxes of each can be purchased, and you've got a maximum amount. So basically, look at the bigger one first, the better deal. How many can be purchased there. Look at how much money you have left over, and see how many of the other type can be purchased. All right, that's kind of just a trial and error, kind of like the boxes that we saw in the previous section. All right, there's several questions in here too that just remind you to always read carefully. Don't jump to conclusions. How many 3-cent stamps are there in a dozen? You'd be surprised how many people, and maybe you're one of them, if so, you're not alone, would look at that and just say, you know what, I'm going to take 3 cents and I'm going to multiply it by 12. Because they see two numbers in there and they figure they got to go together. But if you read it carefully, right, you see the question, it's not about money. So the cents are just not important. All right, all that really matters here is how many. And so there are 12 in a dozen. Right, so again, that's just kind of a little reminder there to be careful when you read. Sometimes there's information that's not important, and so it's a good idea to go ahead and kind of disregard that in the beginning. All right, the one that I want to look at with you here is this one that deals with area. So area is a formula that we need to know. The area of a rectangle is always computed by taking length times width. So if you're told that you want to do something with the length and the width, right? In this case, I want to double, right? So double just means multiply each one by 2. Triple would be multiply each one by 3. All right. So if I double the length and the width, right, then I'm going to be looking at 2 times the length and 2 times the width. And I want to know what happens to the area. Right? Well, all I'm going to do here is write down the new length, which is 2L, multiply that by the new width, which is 2W, and then combine what I can. So if I combine this, right, 2 times 2 is 4, and we're looking at 4 multiplied by length times width. So this is the original area, and what this shows me is if I double the length and double the width, then the area changes by a multiple of 4. And that's just plugging in. This is one of those cases where I like my picture. Plugging in what's happening to the length, what's happening to the width, and then go into your area formula and see how it changed from the original formula, length times width, to the one that you're looking at here. All right. This next one is a question again about miles per gallon. All right. So just remember that's a number of miles divided by number of gallons. Then you've got a pretty straightforward comparison. You're looking at 2 teams, compute their points, right? Who scored the most, who won, and by how many points. Just make sure you look at each part of the question. All right, then you've got one where a proportion can be used. We talked about that in the previous section because you're looking at a relationship between the number of pieces and the cost. All right, so if I do that looking at a proportion, all right, then I'm going to look at the number of candy pieces. So the first thing I'm told is I've got 10 pieces, and I want to divide that by the price. Well, notice for 10 pieces, we don't know that, and so I'm going to make an X there. And then the other relationship given is for 1,000 pieces. And the price there, we know, is $100. And using cross multiplication, right? If I multiply 10 by 100, right, I get 1,000. If I multiply x by 1,000, I get 1,000x. And then the way that I would get x by itself, since this is multiplied, I would divide both sides by 1,000. I would get that x is equal to 1. And so the answer to my question would be $1. Now, there is another way that you could work this one. And so if you did it this way, that's perfectly fine. Because you're talking about money, you could compute a unit price, right? Like how much would one piece of candy cost, and then apply it to the others. And so your unit price would take $100 and divide it by 1,000 pieces. And that would tell you that the candy cost 10 cents per piece. And you get the unit cost, right? Then all you'd have to do here is turn around and apply this to 10 pieces of candy. And that would give you the same thing, right? 10 cents times 10 would be equal to $1 full. Right? So this is another good thing to point out. Sometimes there's more than, in fact, a lot of times, there's more than one way to work a problem. So, just because you don't work it the same as somebody else, that doesn't mean it's wrong. It just means there's different ways to get to what you need to get to in the end.